homework help video page 437, numbers 9 through 20. Let's go ahead and get started with the work today. Actually, I have the wrong book out, so give your teacher 1 second here and I will get the correct book out. Hold on 1 second. Okay, there we go. Numbers 9 through 16, the directions say to find the value of x as a radical in simplest form. So we're not going to solve these, we're going to simplify them. Okay, we have leg. Let's go ahead and write, but we have a right triangle, so we can definitely use Pythagorean theorem. Okay, now one of your legs is x, the other leg is 8, and the hypotenuse is 10. Okay, so let's see what we have. X squared plus 64 equals 100. Bring the 64 over and make it negative. 100 minus 64 is 36. Take the square root of both sides. The square root of x squared is x. The square root of 36 is 6. Okay, so x equals 6. So in this case here, there's really no simplifying to do. 36 is a perfect square, so the square root of 36 is 6. Let's try another one, number 10. Okay, here we go. We have a right triangle, and we know 2 sides. We're missing a third side, so we can use the Pythagorean theorem. Well, one of my legs is 9. The other leg is 40. And my hypotenuse is x. 9 times 9 is 81. 40 times 40 is 1600. Equals x squared. Add these two together and you'll get 1681 equals x squared. Now take the square root of both sides, and this is actually a perfect square. If you type this into your calculator, square root of 1681, you will get 41. And of course the square root of x squared is x. Alright, so the value of x is 41. Moving on to number 11. We have a right triangle. We know 2 sides. We're missing a third side, so we know we can use Pythagorean's theorem to solve for the third side. Okay, one of my legs is x. My other leg is 1. And my hypotenuse is 2. Now, if you square the 1, you get 1. If you square the 2, you get 4. Bring the 1 over and make it a negative 1. So we're left with x squared equals 3. Now take the square root of both sides. The square root of x squared is x, and the square root of 3 is, well, it's just the square root of 3. Now think of your perfect squares, okay? 2, 4, 9, 16, 25, 36, 49, 64, 81, and 100. And by the way, these are not all the perfect squares. That's just usually enough to help us with these problems, okay? So there's my list of perfect squares. Now, do any of these numbers go into 3 evenly? No, they don't. So we're finished. This is as simplified as the square root of 3 gets, okay? So x equals square root of 3. Alright, moving on to number 12. Alright, here we go. We have a right triangle. We know 2 sides. We're missing a third side. We know we can use Pythagorean's theorem. L squared plus O squared equals 8 squared. One leg is 7. The other leg is x squared. And the hypotenuse is 9. Well, let's see, we have 49 plus x squared equals 81. Bring the 49 over and make it a negative 49. And we're left with x squared equals 32. Take the square root of both sides. The square root of x squared is x. The square root of 32 is the square root of 32. Now the directions say to simplify these, so we are not going to type this into our calculator. We're going to simplify it instead. Which one of these numbers goes into 32 evenly? Well, 4 does. does, but there's a bigger number, 16. So I'm going to put 16 times 2, which is the same thing as 32. Cross off the 16. The square root of 16 is 4. So my answer would be 4 square root of 2. Now you know the square root of 2 cannot be simplified because none of these numbers will go into 2 evenly. Alright, moving on. In fact, why do I even have 2 here? That's totally incorrect on my list of perfect squares. That's pretty funny, actually. Alright, 2 should not be there. So if you copy this list down, please take that 2 off. Alright, number 13, here we go. Now, excuse me for yawning. Now, here we go. I have a right triangle, and I know 2 sides, and I'm missing a third side, so I know that I can use leg squared plus leg squared equals hypotenuse squared. One of my legs is 4. My other leg is square root of 5. And my hypotenuse is x, okay? Now, when you square 4, you get 16. When you square a square root, you always get what's on the inside. That's a shortcut, and please learn that shortcut now, students. Whenever you square a square root, you get what's on the inside. And if you want to see a little quick proof of that, I will show you real quick. Watch this. Square root of 5 squared means square root of 5 times square root of 5. Multiply inside number times inside number. 5 times 5 is 25. Well, the square root of 25 is 5, which is what you had on the inside right here. Okay, so I'm telling you, whenever you square a square root, you're left with a number on the inside every time. Now 16 plus 5 is 21. Take the square root of both sides. The square root of 21 is the square root of 21. The square root of x squared is x. Now, do any of these perfect squares go into 21 evenly? No, they do not. So the answer is simply square root of 21. Okay. All right, number 14. We have a right triangle right here, and we know 2 sides. We're missing 1 side, so we can definitely use Pythagorean theorem. So we have leg squared plus leg squared equals hypotenuse squared. Now, for one leg, we're going to put in a 1. For the other leg, we're going to put in x. Then for the hypotenuse, we're going to put a square root of 2. And of course, that's going to be squared because of the formula right here. Now, when you square 1, you get 1. When you square x, you get x squared. And whenever you square a square root, you get what's under the radical. So we're squaring a square root. 2 is under the radical. So out we get 2 right here. Okay. Now bring this 1 over and make it a negative 1. So it's gone. And you end with x squared equals 1. Okay. X squared equals 1. Now take the square root of both sides. The square root of x squared is x. The square root of 1 would just be 1. And so that would be it. The answer is 1. Okay. So the length of x is 1. Alright, moving on to number 15. We're going to solve for x. Students, as you look at number 15, it looks at first like it's pretty simple. Then you realize it's not. Then you realize it is. The first thing I noticed was, here's a right triangle right here. Okay? So I'm doing pretty cool. I mean, this length from here to here is 8. This is x, but then hold it, look, I don't have a number over here. So maybe it's not as easy as I thought. Then it all of a sudden becomes easier because look, forget about this dotted line for a second, students, please. Forget this dotted line. Just pretend you had a triangle drawn like this. And this angle, and this angle, and this angle are all congruent, just like these are. See it? Now, if you have a triangle like that, and all the angles are equal, then we know it's called equiangular. And we know all equiangular triangles are equilateral, which means all of these sides have to be the same. So if from here to here is 8, and from here to here is 8, then this whole side right here is 16, right? So if that side's 16, that means all of these sides are 16. So now it just became really, really easy, okay? Watch. Here's my right triangle right here. Forget the other right triangle. Totally forget this over here. Just forget this, okay? So this length right here is x, this length here is 8, and this length here is 16. Now we're ready to use the Pythagorean So students, here we go. We're dealing with the right triangle, so we can definitely use Pythagorean theorem. L squared plus L squared equals H squared. One leg is 8. Another leg is x. And the hypotenuse is 16. 8 times 8 is 64. X times x is x squared. 16 times 16 is, I think I know that, but I'm not for sure. I'm going to type it in. 256. Okay, now bring the 64 over and make it a negative 64. And we're left with x squared equals 192. Okay, so take the square root of both sides. And x equals the square root of 192. Okay, now these big ones like this are not always easy to simplify. I'll admit that, okay? I'm not going to deny that, but you still need to try to simplify these, okay? So, if you start, I always start with the biggest number and work my way down. If you start with the biggest number and work your way down, does 100 go into 192 evenly? No. Does 81 go into this evenly? No. But guess what? 64 does. If you took 192 with your calculator and divided it by 64, you would get 3. 64 times 3 is 192. Now, you do not know the square root of 3, but you do know the square root of 64. Cross it off and put an 8 on the outside, so you're left with 8 square root of 3. 8 square root of 3, and that is the correct answer. Alright, number 16. Alright, here we go. We're going to solve for x. Now, usually, students, as you progress along from problem to problem, the further you go, the more difficult the problems become. But in this case, this problem here is easier than the last problem. Here's your right triangle right here. Got it? And I know this length is 2. This length is x. I'm missing this length here, but look. This side here is congruent to this side here. So if this side is 3, then this side is 3 here. So now I'm totally ready to use the Pythagorean theorem. So L squared plus L squared equals H squared. So one of my legs is 2. My other leg is 3. And my hypotenuse is x. 2 times 2 is 4. 3 times 3 is 9. 4 plus 9 is 13. Take the square root of both sides. The square root of 13 and the square root of x squared is x. Now, there is no way any of these perfect squares over here will go into 13 evenly, okay? None of these. So you are finished. This is the answer, okay? Now, moving on, we're going to look at some problems here, and the directions say to find the missing ordered triple, or find the missing number to produce an ordered triple. So here we go. My suggestion to you is to pick up these numbers and put them on the triangle. That way you know if you're missing a hypotenuse or a leg, okay? I think we're missing an hypotenuse on this one. Okay, 12 goes here with R. 16 goes here with S. So yes, we're missing T. So here we go. Leg squared plus leg squared equals 8 squared. Can you say redundant? Same thing over and over. 12 for one leg, 16 for the other leg, and the hypotenuse is T. Well, 12 squared is 144. 16 squared is 256. Add these two together and you will get 400. Okay? And the square root of 400 is 20. So 20 equals T. We took the square root of both sides right here, and the answer is 20. Alright, number 18. Looks like we're going to go with side R is 9. And side S is 12. So we're missing T again. So leg squared plus leg squared equals hypotenuse squared. Okay? Well, let's see. One of my legs is 9. One of my legs is 12. And my hypotenuse is T. 9 times 9 is 81. 12 times 12 is 144. If Take the square root of 225 and you will get 15. And take the square root of t squared and you will get t. So t equals 15. Alright, on to 19. Number 19, let's see what we have here, students. We have r is 7 and t is 25. So pretty simple. We're missing s. So we have leg squared plus leg squared equals hypotenuse squared. Okay? Square one leg, that would be a 7. Square the other leg, that would be s. Square the hypotenuse, and that would be 25 squared. Well, let's see here. 7 times 7 is 49. S times s is s squared. And 25 times 25 will give you 625. Now bring the 49 over and make that a negative 49. And we're left with s squared equals 576, I believe. Now, let's take the square root of that number with our calculators, and you will see that you get out 24. The square root of s squared is s, and the square root of 576 is 24. So s equals 24, okay? And finally, the last problem. R equals 35. T equals 37. Solve for s, okay? Solve for s. So L squared plus L squared equals hypotenuse squared. One leg is 35. The other leg is s. And the other leg is 30, or the hypotenuse, excuse me, is 37. Now, if you square 35, you're going to get 1,225. Bring down your s squared. And if you square 37, you're going to get 1,369. Alright. Now, bring the 1225 over and make it negative. And you're going to get s squared equals 144. Obviously, the square root of s squared is s, and also, obviously, the square root of 144 is 12. So, s would be 12. So your ordered triple here would be 12, 35, and 37. That's called an ordered triple. Number 19, your ordered triple would be 7, 24, 25, etc., etc. Okay? Students, I really hope this homework help video has